I apologize for that one ending abruptly. The software that I have only gives me 15 minutes video, so this is why it's chunked out. So apologize for that, but like I was saying, we get 32 inches as our final result. We did a circle minus a rectangle to be able to find our shaded regions. So you're applying a lot of trigonometry here. You had two cases here in order to be able to apply to our formula. So our last example is going to be our higher end a little bit right now due to this remote learning we're doing. So we're going to find the area of a regular polygon. This formula that's here gives us, we can use this formula on any regular polygon, whether it's a hexagon or an octagon or a dodecagon or a pentagon. As long as it's a regular polygon, we're able to use areas equal to 1/2 the perimeter times the apothem. So right now I know I'm going to need the perimeter and I'm going to need the apothem. I'm going to talk a little bit about what the apothem is here in a minute. I do want to make sure we understand what regular means. Regular means that all sides of the shape are going to be congruent. So we know that if this is going to be 8, then that's 8 inches, this is 8 inches, this is 8 inches, 8 inches, 8 inches. So in a way, if we know the center of the polygon kind of makes a circle when we collect it, we kind of can just break this possibly up into triangles. So let's say if we were to cut it here, we have 1, triangle 2, triangle 3, triangle 4, triangle 5, triangle 6, and we know that the outside pieces are all going to be 8 due to the fact that it's a regular polygon. So when I'm doing the perimeter here, I can kind of take the number of sides times that side length, so let's say times s here. So we're going to go here 6 times 8, and we're going to get 48. So right now in my formula, I know area is equal to 1/2 48 times this value that we're going to find here in a minute. So with that said, we've created 6 triangles. So just keep that in mind. I am going to talk about another method that you could do this. A little bit more non-conventional, I'm going to say. Not so much formula-based, but more concept-based. But since this is a regular polygon, and we can break this up into 6 congruent triangles, since it's going to be regular, we know that all these have to be equal to each other. Vertical angles, angle side, and then we know 8, 8, 8. So due to that, we know that all the triangles are the same. We also know that going completely around the circle is 360 degrees. So all of the exterior angles, when you connect these, are going to have to be 360 degrees. So thus, when we do that, if we do 360 and we divide by 1, 2, 3, 4, 5, 6 triangles, if we take 360 and we divide by 6, we get 60 degrees. That tells me that this angle is 60 degrees, this angle here is 60 degrees, and all of these are 60 degrees walking around there. Which means if it's 60 and we have 8, we now know that in a triangle we have to add up to 180. So there's some combination of this that's going to happen. So let's just kind of look at one of these triangles and how it breaks down. So we know this is 60 degrees, and I know this is 8. So if I'm looking to find the height of this triangle, due to the fact, so let's just find the area of it, and then if we do that, we can find 6 of them. If we find the height of this, it's going to kind of end up going right straight down that value. So if we're dropping it from the center here, we're going to drop that height. It ends up being the perpendicular. So because you're splitting that angle, or that side length, this actually is going to break into 2 right triangles. One that's 4. Actually, let's not do that one. We're going to break it into a right triangle here. We're going to go 4, 90 degrees. And since the whole angle was 60 and the side length's being cut in half here, we know that the angle is then going to be cut in half as well. So instead of having a 60 degree angle, now we're going to have a 30 degree angle. So this little angle inside here is found by taking 360 and dividing it by 2 times. So 360 divided by 2 times the number of sides. So instead of 6, if I divide it by 12, it's going to give me this little right triangle angle right here. It's going to give me that angle every single time. So if I had a 10-sided figure, then I'd take 360 divided by 20, and that's going to give me an 18-degree angle. If I had a pentagon, then I would take 2 times 5, which is 10, and 360 divided by 10, and that's going to give me moment. So now I've got my right triangle. The reason that this right triangle is so important, and this is probably the hardest concept to understand when you're doing regular polygons, is this new word called the apothum. Not opossum, not the animal, but apothum. Apothum is a perpendicular segment from the center of the polygon that goes straight down to any side. So this red line that I put in there is actually considered the apothum. So that's the apothum, and then in my picture down here, this is going to be the apothum. That's that A value that we're looking for up here as well. So I want you to think the apothum is the height of the triangle. I think it's the best way of thinking about it, the triangles that are created. And just realize those triangles are all the same. So we're looking for the height of that one. So it's going to be H, looking for the height. Let's get rid of this one. So because we're looking for the height, we know this is 30 degrees, and that's 4, and that's there. We have tangent then of 30 degrees, so of that angle that we found, is equal to 4 over A. And we'll just call it A since we're looking for the apothum, or you can put H, it's up to you. When you solve that, you get A tangent of 30 is equal to 4. And then you get A is equal to 4 divided by tangent of 30 degrees. And when you take 4 divided by the tangent of 30, you're going to get A is equal to 6.9. It's going to be my apothum. So how tall this triangle is, the apothum value will be 6.9. So we'll put that in right here. So again, it's the perimeter times the apothum. Apothum is from the center of the polygon straight down to the value. So just looking at that, and I know this is can be a very detailed picture and hard to find, hard to follow at times. So the one thing that I do want to kind of just show you is if you have a pentagon, in this case, or a hexagon, another way of doing this is we can just simply look at how many triangles are being created. So if you don't want to go the perimeter route and the apothum route, we're still going to need that apothum, but just look at how many right triangles. So just look at one triangle. So since we know a triangle is equal to 1/2 base times height, let's just find the area of this triangle. So let's say if that was 8, let's figure out the height. Now, what you need no matter what is the same thing we talked about here, is this inside angle. You need to know one of these angles that's inside that triangle. So just keep in mind the one formula that we're always going to use when we're looking for an angle is 360 divided by 2n. That will give me my nice angle here, this right triangle that is going to be inside this. So I'll kind of draw it here. That's represented by this triangle right here. 360 divided by 2n will always give you that angle right there, no matter what that side is. So n is representing the number of sides. So the number of sides is put in there. In this case, it's 6, so 360 divided by 12 then ends up being 30 degrees. And that's what got our value. So then we're looking at our base and our height. Well, our base we already have is 8, so we have 1/2, 8. And then our height, this now becomes 4. We just find our height by doing the tangent of 30 degrees is equal to 4 over h. And we're right back to where we did before. So we end up solving for that. We get h is equal to 6.9. So you take half of 8 is 4. 4 times 6.9 gives you just the area of that triangle. So when you do that, and you take the area, you get 27.6 as the area of one of these triangles. So the last thing you do then is you just multiply this by 6. And when you multiply by 6, you get 165.6. And if we go back and look at this one, when you took 1/2 times 48 times 6.9, so 24 times 6.9, you get a 165.6. So notice the values does not matter which way you do it. You can go the perimeter and the apothem route, or you can go the triangle route. And how many of these little wedges do we have? So, but the key is going to be remembering this is going to be to find my angle. Find my angle that I need for my right triangle. And then the apothem, that's how tall the triangle is going to be, is you're going to use sine, cosine, or tangent. Again, that concludes. Hope everything's going well. Thank you for working hard. If you have any questions on this, please feel free to contact your teacher. I apologize for a couple of the mistakes I made, but we're all good. So appreciate the time. Thank you.